Your AI assistant just rolled 3 dice, returned the results, and asked if you wanted to roll again, all from a single natural language request with no custom API code. We'll implement this using FastMCP's tool protocol, where Python functions become AI-callable tools through simple decorators. You'll see how the framework handles the full RPC lifecycle: tool discovery, parameter validation, execution, and response formatting, while maintaining clean separation between your business logic and the transport layer. The example also demonstrates proper security patterns using development-only token utilities, with clear warnings about production requirements. I'll roll some dice for you. Let me use the dice rolling tool. I rolled 3 dice and got 4, 2, 6. The results were 4, 2, and 6. Would you like me to roll again or roll a different number of dice? This demonstrates the AI tool integration pattern, where Python functions become directly callable by language models through FastMCP's MCP protocol implementation. The framework creates a clean boundary between natural language requests and deterministic backend operations, with tools maintaining pure business logic, while FastMCP handles all protocol translation, schema generation, and transport management. The distinctive feature is how tools expose typed interfaces through decorators, while the framework manages the complete RPC lifecycle from discovery to response formatting. The pattern works through declarative tool registration, where at MCP, tool decorators transform Python functions into MCP-compatible endpoints, automatically generating OpenAPI schemas from type hints. FastMCP handles the full interaction flow tool discovery via /MCP endpoints, request validation, execution, and response serialization, while supporting both simple execution, like the dice roller example, and complex elicitation patterns where tools may return no data but require approval. Authentication integrates through configurable providers like JWT Verifier, with clear development testing utilities like RSA key pair that should never be used in production. This approach eliminates manual API boilerplate while maintaining type safety and security controls. It's particularly valuable for creating AI-callable utilities where you need strict input validation, but want to avoid writing custom transport layers. The trade-off is framework dependency, but the benefit is removing hundreds of lines of manual root definitions, serializers, and protocol handlers, letting you focus on core logic, while FastMCP manages the AI integration layer with proper environment isolation and production-ready security patterns. Let's break it down line by line. I'll roll some dice for you. Let me use the dice rolling tool. This declares the AI's intent to execute the registered dice rolling tool function. FastMCP's protocol intercepts this message, routes it to the decorated Python function, and manages the full RPC lifecycle from discovery to response formatting. The framework maintains natural language flow while strictly separating conversation from tool execution. I rolled 3 dice and got 4, 2, 6. This formats the dice roll results as both human-readable output and structured data for AI processing. The response shows the quantity rolled, individual outcomes, and maintains compatibility with FastMCP's tool response protocol while enabling immediate follow-up actions like re-rolling. Unlike elicitation patterns that require approval, this executes directly and returns concrete results without additional validation steps. The results were 4, 2, and 6. Would you like me to roll again or roll a different number of dice? This implements FastMCP's elicitation pattern for interactive tool workflows. The response type equals none configuration explicitly declares no structured response data is expected, only approval or rejection signals, while literal types constrain user options to predefined choices. The framework manages the full RPC lifecycle from discovery to execution, with tools optionally exposed as HTTP endpoints while maintaining environment isolation. Elicitation pattern. FastMCP's context elicit transforms natural language into typed interactions, where response type equals none explicitly signals approval rejection without data payloads. Constrained responses enforce domain-specific options through literal types or string lists while preserving conversational flow. Tools execute in isolated environments, yet expose HTTP endpoints through automatic schema generation from Python type hints.
The decorator that names the tool erases its implementation.